In this tutorial we're going to look at the circle theorems. Now there are quite a lot of these, and quite honestly the best way to learn these is simply to use them over and over again. That's so often true with maths. I'm not going to run through all of these in great detail, but the things you need to remember are these things in quotation marks at the bottom of each one. Angle at the centre is twice the angle at the circumference, x is twice y, and so on and so forth. Angles in the same segment are equal. Well, what's a segment? If I join those 2 points, the segment is the thing above the line, and in fact the little one below the line, and any angle I draw in that segment are equal, so x equals y. If we have a cyclic quadrilateral, then the opposite angles there add up to 180. If we have a tangent and a chord, then the angle between the chord and the tangent is equal to the angle in the alternate segment there, the other segment on the other side of the chord. Angle in a semicircle, in other words, if I draw a diameter, then any angle I draw in that semicircle is a right angle. If I ever come across two radiuses, that makes an isosceles triangle like that. A radius and a tangent always meet at right angles. And finally, if I take a point and I draw a tangent to the circle from each of them, I get exactly the same length line. And in fact, that shape there is a kite because it has two pairs of equal sides in that way. Right, so you need to learn those. Let's have a look at a couple of questions though. Here's the first one. Find the angle of the size of the angle BCD, that's this one down here, giving reasons for each step in your working. And that's where the green lines come in. Okay, you do need to know the reasons. So let's have a go. Well, I don't think I can get there directly because this is not a cyclic quadrilateral. But I could find the angle BAD first. And often with these questions, it is a case of just finding angles that you can. So given 110 there, I can find BAD using this circle theorem here. So let's do that. The angle BAD, I'll put the hat on it to show it's an angle, is a half of the angle BOD. And I do need to give a reason, and the reason angle at centre is fine, because although it should say angle at centre is twice the angle at the circumference, I have shown that I know that's the case with this half here. So a half of BOD, not BOB, BOD is a half of 110, which is 55 degrees. So I found that angle there. Now, does that allow me to find BCD? Yes, it does, because now I have this shape here, which is a quadrilateral with all 4 points on a circle. In other words, it's a cyclic quadrilateral, and opposite angles in a cyclic quadrilateral add up to 180. So the angle BCD, which is what I'm trying to find, will be 180 minus the angle BAD. And I need to write down opposite angles in a cyclic quadrilateral. And because I'm feeling a little bit lazy, I'm going to write CQ. You should probably write cyclic quadrilateral. So that's 180 minus 55, and 180 minus 55 is 125 degrees. And as I say, if you can't think what to do, just find some angles that you do